Okay, today's lesson is section 8.1 out of our textbook. It's called Inverse Variation, and I hope you all think it's a pretty easy lesson. Okay, to start off with, okay, it says remember, because this is something you should know, direct variation is an equation that has the form y equals kx. And I should have started this, y'all. This lesson is dealing a lot with word problems, the variation. It's very real world. We see this a lot, okay? Very practical. But I will tell you, these are my favorite kind of word problems because they give you a definition of how you do it, and it doesn't ever change. If you know this translation from English to math, you will be able to handle any kind of word problem that deals with variation. Okay, so the first one is direct, y equals kx, or if you solved it for k, that would be k equals y over x. Okay, next, or now, we're going to talk about something called inverse variation. An inverse variation is an equation that has the form y equals k over x. Or if I solve that for k, it would be k is equal to xy. I multiply the xy values to get that constant, okay? When two quantities, and actually, let me go back to this and remind you, come here. Y equals kx is what we've had before, and if you graph it, it looks like that, which if you remember, k is often referred to as m, so that would be the slope. But what this is telling us is as x increases, y increases, and that's why our line looks like that. Okay, so the difference now with inverse variation is when two quantities vary inversely. As one quantity increases, the other quantity decreases proportionally, and k is called the constant of variation. So what you should be able to do is look at a table of values and decide whether the relationship between the variables is a direct variation, an inverse variation, or neither. And so what we're going to do is if it's, well, here's the inverse, excuse me, the inverse variation. We're going to look at the values and see if we get the same thing every time we multiply x and y, or we're going to look and see if we get the same thing every time we divide them. And if you're wondering, if you have any kind of trouble telling whether or not which one goes on top, remember this is like the slope of a line. And the slope of a line is the change in y over the change in x. So the y is going to be on top whenever you're dividing like that. So to do this problem, I'm going to look at, it's easier to multiply. So I'm going to actually go look and see what happens when I multiply these values. So 8 times 0.2 is 1.6. And 0.5 times 20 is 10. So since those are not the same, then we do not have, what happens on multiply is inverse. So I do not have inverse variation. Okay, so the next thing I'm going to do is look and see what happens. And you can do it with the same numbers, y over x. If I divide 8 by 0.2, then that's going to give me 40. And if I do 20 divided by 0.5, I'm going to get 40. And so I have the same number. You can look quickly. 40 divided by 1 is 40. Okay, but that's enough to tell us that this is direct variation. And so once we decide what it is, then we have to write a function model. And that function model is when we get into these equations. And we talked about this for our last test. A function model has two variables in it. So you're going to give me that equation with a y and an x in it. Okay, so if I come back to my pen, this one, and the nice thing about it is when you do this kind of thing right here, y over x or xy, that's what k is equal to. So in my direct variation, y is equal to k times x. So that's what that looks like. All right, let's look at another one. We have, first I'm going to multiply them just because it's easier. So 0.2 times 40 is 8. 0.5 times 16 is 8. 1 times 8 is 8, so we're good enough. Again, but that's multiplying, and so that tells me that this is an inverse variation. And again, whatever I get when that number is the same every time, that's my k. And my inverse variation formula is y equals k, which was 8 in our problem, over x. So this is our equation. All right, let's look at the next one. Excuse me. So we have, if I multiply the numbers, 0.5 times 40 is 20. 1.2 times 12 is 14.4. So it is not, multiplying is inverse, so it's not inverse. And then I'm going to come over here and divide those. 40 divided by 0.5 is 80. And 12 divided by 1.2 is 10. And those are not the same, so we know it's not direct. And therefore, the answer to this one is neither. Okay, so the next thing that you got to be able to do, suppose x and y vary inversely when x equals 8 and y equals -7. What is the function that models the inverse variation? So if they tell me inverse variation, I know that's y equals k over x. Okay, if I have to write the model, then I got to know what k is. And whether you plug them in there or whether you choose to remember that k is equal to x times y, doesn't matter. So k is equal to 8 times -7, which is -56. So my model is y equals -56 over x. I'm just plugging in for my k value to get that model. Okay? Now, what does the graph of this function look like? Okay? And I'm going to tell you, and we're going to talk about it more in the next lesson. But to graph these things, we're going to do a very simple way. If you'll do this, it'll make it not very easy. Okay? What does the graph of this function look like? Well, I can go get 4 points very easily if I know that every time I multiply the x, y values, I got to get the same thing. So I already know that I have 8 and -7. Well, I also am going to have -8 and 7. And I'm going to have 7 and -8. And I'm going to have -7 and 8. And so if I go plot those points, I'm going to tell you, it's a rough estimate, y'all, that it's going to look something like this. I'm going to have one like this and one like this. So I can go label this point. If I label that point is went over further down. It's an estimate, y'all. So this would be the point 8, -7. And this point here would be, that one would be 7, -8. And if I come over here, I would have that point, what's that going to be? -8, 7. And this point would be -7 and 8. Okay, so we're going to talk more about that in the next lesson, but that's just a rough estimate, an easy way to graph that. Okay, so that was kind of part B. Part C says, what is y when x equals 2? So I'm using this function that we just got. What does y when x equals 2? Y is -28. All right, let's look at a word problem. It says, after a major storm, your math class volunteers to remove debris from the yards. The table shows the time t in minutes that it takes a group of n students to remove the debris from an average size yard. And then it gives you your chart. What function models the time needed to clear the debris from an average size yard relative to the number of students who do the work? So a couple of things that we have to talk about. When you see this chart here, okay, when it goes sideways, think about the fact that we read from left to right and top to bottom. So this is the same thing as your x, and that's the same thing as your y. Okay, so if there's any kind of question. So if I'm trying to figure out what kind of function I have, I'm going to first multiply the numbers. 225 times 1 is 225. And 3 times 75 is 225. 5 times 45 is 225. So we're good with the fact that I multiply, that is my k value. And if I multiply and get the same thing, then I'm going to know that that is an inverse variation. So that means y equals k over x. And we just figured out that k was 225. Now, we do need to put this in terms of n and t. So as I just said, x is your n. So this is going to be t equals 225 over n. So that is the model. Part B says, how many students should there be to clear debris from an average size yard in at most 25 minutes? Well, 25 minutes is clearly the t value. So I'm going to go plug in 25 equal to 225 over n. Now, what I talked to y'all about before is you can cross multiply. You can put this over 1, cross multiply, and then divide. But I want to tell you, because we're going to see this a lot later on, but when you have an equation like this, if the variable's on the bottom, you can actually switch those two. It's the same thing you're going to get when you cross multiply and divide. So, kind of an important thing to know because, like I said, we're going to use it a lot coming up. Anyway, so n equals 225 over 9, so n equals 9. And the answer to my question is, how many students? It's a word problem. We put a label, 9 students. Okay? All right, so when you turn your note sheet over, we have some other forms that you're going to see. And what I want to point out to you, okay, is the key word that you need to find when you're doing these problems is whether or not it has inversely in it. Because if it has inversely, then that means there's something in the bottom. W's in the bottom here, WY's in the bottom there. If you don't have inversely in there, then everything is up on the top. Z varies jointly with X and Y. Z equals KXY. Z varies jointly with X and Y and inversely with W. Whatever's after inversely is going to be on the bottom. Okay? So look at these. No, come here. Look at these next problems. It says P. Actually, what you ought to do is pause it. See if you can figure out what goes in the blank. And then turn it back on and see how you did. So P equals KTN means P varies jointly with T and N. M equals KY over XN. That means M varies jointly with Y and inversely with the product XN. 14. V equals KRM over Z means V varies jointly with R and M and inversely with Z. So this is what I'm telling you when I say, to me, these are the easiest word problems ever, because if you understand this translation from English to math, then you're good to go, because it's not going to change. All right, so let's look at one more word problem, and then I actually do some problems that I have you do for homework so that you don't get confused by the directions. Okay, so this says the number of bags of mulch you need to cover a planting area varies jointly with the area to be mulched, A, in square feet, and the depth of the mulch, D, in feet. Okay, that sentence, y'all, gave you no numbers, but it gave you a lot of information. That's what we're going to translate from English to math. Here's one variable, my area in square feet, and then they gave me the depth. All right, I need another variable in here because I'm going to have 3 numbers, and it's the number of bags. So you can choose whatever letter you want. Most of my students wanted to choose the letter B, so that's what we're going to use. And so the key that what you're looking for when you're trying to figure out which variable is all by itself, it's the one that comes before the word varies. So here I have the word varies. So I'm going to say B varies, always have to have a K, and it's jointly. There's no inversely, so there's nothing going to be on the bottom. There's no word inversely in there. So K times A, D. Now, if they don't ask me for a function model, I'm not going to find k. What I'm going to do is solve for k, which you do by dividing by those. Okay, those go away. So k is equal to b over ad. And I'm going to use that to write a proportion. So b over ad, so it's going to look like this. Okay, B stands for the number of bags. They tell you this right here, y'all. This is the key that you know. I need 10 bags for an area of 120 and a depth of 3. And then it says how many bags do you need to mulch an area of 200 to a depth of 4. So those are the numbers that I'm plugging in. Oh my goodness, hold on. Okay, I'm back. So we cross multiply. 10 times 200 times 4 is 8,000. And 120 times 3 is 360b. So when you take 8,000, divide both sides by 360, you're going to get that b, that's a bad looking b, b is equal to 22.2. Okay, it's a word problem. You got to figure out what makes sense to answer the question. Okay, the question says, how many bags do you need? Can you buy 22.2 bags? You cannot. Will 22 bags cut it? No, it won't, because you will not have filled up the whole thing. So the answer to the question is 23 bags. Okay. So that's the word problem. I have 2 more examples of problems because I wanted to make sure you knew how to do these in your homework. Okay, this problem here, write the function that models each variation. Find z when x equals 4 and y equals 9. So when you get to 27 and 28 and you don't know what to do, come back to this video and look at this, because these have the same directions. Okay, so these directions right here apply to 27 and 28. These directions inside here, what makes each problem different. Okay, so z varies directly with x and inversely with y. So I have an inversely, and that means it's going to go on the bottom. Directly goes on top. And it's telling me to, when x equals 6 and y equals 2, then z equals 15. So this is the, I do have to find the model. So this says find the function. So I got to figure out what k is equal to. And k equals yz over x. And so what is y? They said y is 2 when z is 15 and x is 6. Is that what that says? All right, and so that means k equals 5. And y'all, it doesn't matter. I solved it for k. If you want to plug those numbers in right there and find out what k is, it doesn't matter. Whichever is easier for you and what you can remember to do. So that's my k. And now I'm going to write my function. So it's going to be z equals 5x over y. That's my function model. The second part that I have to do, it says find z when x equals 4 and y equals 9. So I'm just going to plug in 5 times x over y. I plugged in my numbers, and I'm okay with you leaving that as a fraction. 20 over 9. All right, last problem. Each pair of values is from a direct variation. Find the missing value. Okay, they told me it was a direct variation. So if it's a direct variation, that means y equals kx. That's just the one I've memorized. If I don't have to give a model. Since I don't have to give a model, I'm going to use k equals y over x. And I'm going to set up a proportion of y over x. So 6 over 4 equals 3 over x. Cross multiply, 6x equals 12. Divide by 6. And x equals 2. And that is all that I have to say about inverse variation. If you have any questions, please email me or come see me. Thank you very much.